Let's have a look at set 3. In a coaching class, some of the students registered for online and some other students registered for offline. No student registered for both online and offline. Very clearly given to you. Online students, offline students. That's all, right? And no student register for both online and offline. Hence, the total number of registrations is the sum of online and offline registrations. That's also given to you. The following facts and the tables pertaining to these registration numbers for the 5 months from January to May 2023 is given to you. The table shows the minimum. This table is what they're referring to. This table shows the minimum, maximum, and the median values for both online, offline products as well as the total as well. So minimum of the total is 110, maximum of the total value for any particular month is going to be 130, and the median value for all of these months put together in terms of the total will be 120. That's what the table is reflecting. Now, separately for online, offline, and the total number of registrations, the following additional facts are known. Now, before we move any further and evaluate these 5 facts, let's make a table and try to understand what all values can we figure out for the months for online, offline, and the total values. Okay, so January to May is what they're talking about. So I'm taking January, February, March, April, and May. Okay. Now you are looking at the online product, offline product, as well as the total. So let's quickly construct the table. So online, offline, and the total value that we are looking at. Now let's one by one understand the clues. In every month, both online and offline registrations numbers were multiples of 10. So we are only dealing with multiples of 10. Looking at maximum, minimum, we understand that if I'm looking at online, it has to be 40, 50, 60, 70, 80, 90, and 100 maximum. And 80 in such a way that 80 turns out to be the median of all the data points given to you, all for these 5 months. Same way, it has to be between 30 to 80 for offline product, 30, 40, 50, 60, 70, 80, such that the median is 50. We also have to take care of the total. So this is the first data given to us. There's not much of a relevant in terms of an exact number, but we know everything now over here in this table will be a multiple of 10. In fact, the total will also be a multiple of 10 because the constituents are the multiples of 10. So that is also not a problem with us. So now if you look at 110 as the minimum for the total, 130 as the maximum for the total, and median is 120, that means you only have 3 totals possible, which is 110, 120, and 130. That's all. Second, in January, the number of offline students registration was twice that of the online registrations. So suppose if the online registrations in the month of January was A, then the offline registrations will turn out to be 2A. That is going to be the total. So we realize that it should be 3A as the total. Now, if it is 3A, the totals possible, the total values, the values for the totals possible are what? 110, 120, and 130. We realize that if the total has to be of the format 3A, then A has to be an integer and the total value must be divisible by 3. The only total possible value which is divisible by 3 is 120. So we right now know that the value of A, because 3A will turn out to be 120, the value of A will turn out to be equals to 40. This is something that we very clearly know. So we go back to this. In January, the number of offline registrations was twice that of the online registrations. Online registrations must be 40. The offline registrations will be twice of that, which will be 80, and the total will then become 120. So we have the total for the month of January now. So this is the data that we have already used. We will not be able to figure out anything more using this particular data. So first 2 data points we have consumed and we have the necessary information in our table. In the month of April, the number of online registrations. In the month of April, the number of online registrations was twice the number of offline registrations. Now, if I take the offline registrations as B, then the online registrations will become 2B. Once again, we realize that this total will become 3A. Now, if 3B, and if this total becomes 3B, B has to be an integer. That means the only possibility is this is also becoming 120. That means the value of B is turning out to be what? B is turning out to be 40 now. So where was B? B was over here. So now it was saying that the number of online registrations was twice. So online registrations was twice. That means online will become 80 and the value of B was 40. So this total is also turning out to be 120. So this information has also been consumed. There's nothing more that we can figure out using this particular information. Now, the number of online registrations in March, the number of online registrations in March was same as the number of offline registrations in the month of February. So if I take this value as C, then this value will also be C, is something that this information is telling me. There's nothing more that I can derive out of this. I only have to take care of this particular thing, that always the number of online enrollments for the month of March will be equals to the number of offline registrations for the month of February, right? So this information has also been used. The number of online registrations, which registrations are we talking about? Online registrations, was the largest for the month of May. For the month of May, it should be the largest, right? So if I look at all the months for online, the month of May will give me the largest. That is given to me. What is the online registrations largest value? 100. Now online registrations largest value is 100, and offline registrations the minimum value is 30. If I take any value beyond 30, suppose I take multiple of 10, beyond 30 will be 40. So 100 plus 40 will become 140. We know that the total can only rise up to 130. So what will I have to do? I will have to put a 30 over here, and this value will then become 130. So these are the values that we have at the moment, and I don't think we can derive anything more than this. Now, if you look at the table, there are about 6 values which are unknown to us, which is the online and offline and the total values for the month of February, and so is the case for the month of March as well, that we don't know how many online registrations, how many offline registrations, and how many total number of registrations, right? Now we need to also understand a few more things about this entire data. When we say that your median value of the total has to be 120, we already have got 120, 120 and 130 over here as our totals possible. We have not gotten down to the minimum total possible, which is 120, 110, right? So out of these two values present over here of the total, one of the values has to be 110 for sure, because if it is not 110, then this table becomes incorrect. Why? Because it says that the total minimum was 110 and we have not gotten down to 110. So either this value or this value present over here has to be 110. There is no other way out. That's the first information. The second information that we need to understand is we have to ensure that the maximum, minimum, and the median values are satisfied for both the products, which is online and offline. Now, let's have a look at what is it to offer to us. Now, if you look at the offline enrollments, 30 to 80, and the median is 50. So I'm writing offline over here. And we have gotten down to the minimum value, which is 30. We definitely know the month of May, it was 30 offline enrollments, right? Maximum offline enrollments was 80. So maximum offline enrollment 80 is also something that we know in which month it is, which is January. And the median was 50. And the median was 50. This value of 50 has yet not been allocated. We've already allocated a value of 40. So I'm putting a 40 over here. So we have 30, 40, and a 50 needs to be allocated. So now we know that one value definitely has to be 50, and one more value over here should be either 50 or greater than 50. Why greater than 50? Because if it is greater than 50, then only it will come on this side. If it turns out to be lesser than 50, then there will be one more value that will come on this side, which will then ensure that 50 is pushed next, and then that value 50 does not remain the median. So if 50 has to remain the median, then the other value for offline after 50 has to be either 50 or greater than 50. That's something that we know, right? So we know one of these values has to be 50. Now, I understand that there is a value C over here, which will then become same. So if I presume something for C, then this blank also gets filled. And we also know that one out of these two values have to be 110. So let me presume some of the values and see what table can I make, because I've consumed all the 5 points over here. So let me take the value of C as 50. If I take the value of C as 50, then what happens over here? This also becomes 50. Now, if you look at the online arrangement, if I exclude this 50, what all have I gotten down to? I've gotten down to minimum value of online product, which is 40. I've gotten down to the maximum value of the online product, which is 100. So these two values are fixed, and we know these two values. What is the median of the online values? 80. This is something that has also been fixed, which is for the month of April. Now, if you take the value of CS50 over here, this is 80. And if you take a value of CS50 over here, this value will come over here, right? If this value comes over here, then either this particular value should be 80 or greater than 80. That's what we are looking at. So if you have this as 50, then this is 50. Then there is one more value possible for online, which is present over here, which we don't know at the moment. So what are we going to then put over there? We will have to ensure that this value is either 80 or greater than 80. Now, if you take 80 over here, 80 plus 50 will then become 130, which is a possible outcome. But if you take 90, then 90 plus 50 will then become 140, which is not possible. So if you have taken C as 50, this value is 50, the only possible value for online is going to be 80. And this then this is going to be what? This is going to be 130. Now we understand that one out of these two values had to be 110. So if this is 130, then this has to be 110. If this is 110, then this has to be 60. Now, please understand, once I had taken these two as 50, I realized that I cannot change this value. The only possible value is 80. So there is no more variation possible. If I fix this 50, this is 50, no more variation possible over here as 80. And if I have to satisfy the entire data, then this has to be 60. We will have to just recheck once that we have followed this particular part also or not. So if you look at your offline enrollments, it is 80, 50, 40, 30 and a 60 has come over here, which would then ensure that your median remains 50 and everything falls in place for us, maximum, minimum, and the median falls in place for us for offline enrollments. For online enrollments, what happens? You have a 40, you had an 80, you had an 80 over here for the month of April, and you had a 100 also over here. Now you have taken a 50 over here, then the other value has turned out to be 80. So this is also satisfying. So this is one of the tables possible by taking CS50. Second important point that you need to understand is if you take CS50, then there is no other possibility for the rest of the values. That means the only case possible with C50 is this. Now, we also have to check for the fact that if C is not 50 and the other value turns out to be 50, because out of these two values, one of the values has to be 50, because for the offline, the median value is 50. So we have to place a 50 somewhere. So I've taken C as 50. Now I'm going to take this value as 50 and understand what else can happen. So if I take the value of, I'm looking at only February and March, the rest of the values are fixed. So only this particular row and only this particular row, these two rows, the values were not decided. So I'm only writing these two rows over here for online and for offline product, and try to understand the total as well by choosing the values and see what other values can we fix. So I've just pulled out a part of the table and try to play around with this. This value was C and this value was C. Now we have already presumed C to be 50. So we are not going to get into that case. That case is over for us. Now we are going to get into the case where I'm taking the offline value for the month of March as 50. If I take the offline value for the month of March as 50, then we need to understand a few more things about the data of offline. So if you look at the data of offline, then you have a 30 already decided. 30 is fixed, already done. 40 is fixed, already done. We needed a 50. We kept a 50 over here, right? So the other value has to be either, and then 80 is already fixed for us for offline. So then the next particular value present over here for the offline value has to be either 50 or greater than 50, because less than 50, it is going to dislodge 50 from here, right? So that's not possible. So if I keep this 50 over here, then this value has to be either 50 or greater than 50. Now, if you take the value of C as 50, then the problem is this C also becomes 50. If this C also becomes 50, then the problem is that the total will then become 100 over here, which is not possible because the total has to be 110, 120, and 130. So for this particular value, I cannot put a 50 for the offline case, right? Because the total is not matching, right? So let me remove this 50 and let's see if there are other values that I can put over here or not. So if I take this as 50, then I'll have to take this value over here as either 50 or greater than 50. So I'm not putting 50 over there. So I'm now going to try a 60 over there. If I try a 60 over there, I'll get a 60 over here also. I'll get 110 over here. So that possibility is counted over here, that a total has to be 110. Now let's have a look at the online figures. And now if in the present format, I don't have this 80 over here. This 80 is blank over here. Now you have 40, 50, 80 and 100 as the values that I already have. So I have the online product as 40. I have the online product as a number 40, a number 60, a number 80 and a number 100. That means this leftover number, because this is 60, 80 was fixed, 40 was fixed and 100 was fixed. So 40 was fixed, 80 was fixed, 100 was fixed and 60 is something that I'm getting over here, presuming it over here. So 40, 60, 80. So this number either has to be 80 or greater than 80. So if you put a number 80 over here, then what is going to happen? If you take this number as 80, this will become 140, not possible. Greater than 80, that means 90, again not possible. So a 60 over here is also not possible. So with a 50 over here, I've taken into account 50 over here, not possible. 60 over here, not possible. Let's go further and try to test what more can I put at this particular place with a 50 for offline March as a possibility. So if I take 50, I've taken 50 already over here. I've taken 60 already over here, not possible. So I take 70 over here. Now, if I take 70 over here, I'll get a 70 over here. That means 70 plus 50 will then turn out to be 120 for us. So if this number becomes 120, that means this value becomes 120, then one out of these two values has to be 110, right? So this value, if I want to keep 110, then this value I'll have to keep 40. Now let's see if the online assessment matches with ours or not. So if you take the online value as 40 and 70 over here, then what are you getting? You are getting a 40 over here, you are getting another 40 over here. So you have a 40, you have a 40, then you have a 50, you have a 40, you have a 40, you have a 50 over here, then you have a 70 over here. Sorry, no, you don't have a 50 over there. You have a couple of 40s. You have a 40 over here. At the top, you have a 40 over here. Second value is 40. The third value is 70. Then the value is 80. And then the value is 100. Now, no more for the online product, you have the median as 80. Now you have the median as 70, which is not possible because this data cannot be faltered upon. So this 70 is also not possible. So if this 70 is not possible, I'm removing all the possibilities from here. And I now am left with a possibility of an 80 over here. If I take an 80 over here, I keep an 80 over here. In that case, what happens is that the total goes for a toss. Let's have a look at this. If the total goes for a toss, this becomes 130. If this becomes 130, then I need 110 over here because one of the two values have to be 110. This is 80 plus 50, 130. So this becomes 110. If this becomes 110, then this has to become 30. For the online, minimum was 40. This becomes a 30, which is again not possible. So an 80 as a value with a 50 over here is also not possible. So I'm removing all of these values. Now post this, what happens? If you have a 90 over here, if you have a 90 over here, then the problem is you will have a 90 over here, and 90 plus 50 will then become 140 for you over here, which is again not possible. This will become 140, which is again not possible. So with a 90 also over here, it is not a possibility. And then beyond 90, it does not make sense to check anything because then you will have 100 over here. So 100 plus 100 will then make it 150 over here. So anything beyond that is also not possible. So what we have now gotten down to is that a value of 50 over here is not possible. With a value over here at 50, you have only one case. So effectively, after solving everything, we realize that this case does not match. So the only case that stands for us on the basis of which we should answer everything is this particular case. Let's try to look at all the questions and try to understand what are the answers for each of the questions that have been asked to us. I'll let the data be here itself and let's move on to the questions. So this happens to be your first question. Your first question says, what was the total number of registrations in the month of April? Just give me a second. Let me remove this also. Okay. So now what it is talking about is, what is the total number of registrations in the month of April? April, the total number of registrations was 120. So 120 becomes the answer for this particular question. Second question from the set, what was the total number of online registrations in January? Total number of online registrations in the month of January was 40. So you have 40 as the answer for the second question of the set. The third question of the set, which of the following statement can be true? Can be true. We have just one outcome possible for us, and we have every value being fixed over here. So we will just try to look at which of the following is true. The number of offline registrations was the smallest in the month of May. The number of offline registrations for the month of May was smallest, 30. Yes. So the first statement is true. Look at the second statement. The total number of registrations was the smallest for the month of February, 130. No, that's incorrect. So which one is correct? Only one is correct. So option C then becomes the answer for the third question of this particular set. Let's look at the fourth question of this particular set. What best can be concluded about the number of offline registrations in the month of February? Offline registrations in the month of February is 50. Option A. There's no other possibility, neither 30, 50, 80, nothing to it, right? Only one possibility, which is 50. Last question from the particular set. Which pair of months definitely had the same total number of registrations? Same total number of registrations. Is January and April having the same total number of registrations? Yes. So the first statement is correct. Is February and May having the same number of total students registered? February was 130 and May was also 130. This is also correct. So which of the following pair of months definitely had the same total number of registrations? Both statement 1 and 2 are correct. With that, we conclude the set 3 of this particular slot.